Okay, welcome to adding and subtracting fractions. And I know that drives a lot of people crazy, the F word, fraction. But what we're going to talk about here is in this adding and subtracting rational expressions, we need to come up with, in order to add or subtract a fraction, you have to have a common denominator. And we are going to find that the least common denominator is going to be the easiest thing for us to do because that will keep our numbers smaller. So we're going to build equivalent fractions. And in doing so, what we're going to do is learn how to find out what all those factors are to give us those least common multiples. Now with that, looking at this first example, what is the least common multiple of this expression? In A, it's okay, and the first thing that we want to do is we want to completely factor each expression. And this first expression we can do by factoring out the greatest common factor. And then the next expression, it looks like that is a quadratic equation, so we should be able to factor it at this point in time. If you can't factor a quadratic equation, we really need to work on some remedial help. But you should be able to do this, that you know that the factors of -6 that are going to combine to give you a -1, and that's going to be -3 and a +2. So now that we've factored those, what we want to do is we want to make a list of all the possible factors. So combining these, what we have is we have 2 is a possible factor, and then we have x plus 2 is a possible factor, and yes, they both have one of those. And then, or I guess we'll just say x plus 2 again here, and then the next one is going to be x minus 3. Now that we've made a list of all the possible factors, what we want to do is we want to remove the duplicates, and the duplicate would be that additional x plus 2 because each one of these only has 1. They only have 1, so my least common multiple is going to be 2x plus 2 and x minus 3. That's my least common multiple. Okay, so what we did was we completely factored each expression, and then we made a list of all the possible factors, and then we crossed off any repeated factors because right here we had x plus 2 to the first, x plus 2 to the first, and so we went ahead and crossed off one of them because we didn't need 2, and then it says multiply all the remaining factors. So we brought everything down into one composite answer. So there we go. Those are the process that you want to use. And as we go to this next example, what are my possible factors here? So let's go ahead and factor everything. And this becomes x plus 4, x minus 1. And this next one becomes x plus 4, x minus 2, and this next quadratic becomes x minus 2 squared. And so what we do is we make a list of all our possible factors, and we have, let's see here, x plus 4 to the first, right? We have x minus 1, x plus 4 to the first, x minus 2, and then we have x minus 2 to the second. And the repeated things, what do we have repeated here? Well, I already have x to the fourth once, so I can cross off the repeated. I have x minus 1, or I'm sorry, I said x to the fourth. I meant x plus 4 was repeated, so I crossed it off. I have x minus 1, and I don't have any other, so I don't cross anything off. And then here, I have x minus 2 squared. Well, if I have it squared, I don't need it to the first. So that x to the first would be a duplicate. And now I'm going to go ahead and rewrite them as a multiplication problem, which is going to be x plus 4, x minus 1, and then x minus 2 squared, and that is my least common multiple. And as we continue on with this, the reason we want to be able to find the least common multiple is because right here when we go to start adding these, we need to come up with the least common denominator. So what are we going to do? Well, let's start with factoring, completely factor each expression. And when we're factoring the expressions, we're really just worried about factoring the denominator. So I have x minus 1, and I have, well, x, and so if I factor out an x there, that leaves a x minus 1 behind, and then x minus 1, and then looking at that, I want to remove all my extras, and that would be an extra. That is repeated. I don't need it twice. I only have it listed once. Now I have my least common denominator is going to be x minus 1 times x. So, well, when we come over here and we take and we have x minus 1 and x plus x minus 1 and x, and we can go ahead and rewrite the rest of our problem. And when looking at this right here, my new denominator, and as I create this equivalent fraction, I have multiplied x times my original denominator. So if I multiply the denominator times x, that means I need to multiply the numerator by x because it's equivalent and I can't change its overall value. So x divided by x is 1, so this is actually just multiplying it by 1. Okay, and then my second, it's going to be plus, and then this thing over here, my second term is the denominator has not changed, so my numerator will not change, and I need to go ahead and work on this, and I have x minus 1 times x is my denominator, and if I go ahead and multiply this out, I get x squared plus x, and then of course I need to minus 2 from that, and that will become x plus 2, x minus 1 over, because I'm factoring it here, x minus 1 and x, and then of course we should be able to simplify x minus 1 divided by x minus 1 is 0, and then therefore I have x plus 2 divided by x. So there we go. We have what is the sum of that rational expression, and that is it. Looking at this next example, remember the first thing that we want to do is we want to factor our denominator. So this becomes x minus 2, x plus 2, or let me do it up here, and then this is x plus 2, and now that I've done that, I want to make sure that I go ahead and write all my possible factors, and that gives me x minus 2, x plus 2, and then x plus 2. Now both of those x plus 2's are to the first, so I can remove my duplicate. So my new common denominator is going to be x squared minus 4, or as we look at this, x minus 2 times x plus 2. So we go ahead and I'm going to rewrite my new equivalent denominator with its common denominator, and then I have, okay, so it looks like to look at this, my denominator over here has not changed, so I just need to rewrite my numerator, but the denominator on the denominator over here, my second expression, I have multiplied it by, I used to have x plus 2, well now I've multiplied it by x minus 2, so I need to make sure that I multiply both the numerator and denominator by that, and then of course I had a 1 there to begin with. So this becomes new equivalent. I have x minus 2, x plus 2 is my denominator, and then I have x right here plus x minus 2, which is going to equal, combining like terms, 2x minus 2 over x minus 2, x plus 2. And that is as simple as this expression is going to get. We don't need to factor that numerator because it's not going to do us any good to factor it. And we don't need to multiply the denominator back together because it's okay to keep it in factored form. That's an equivalent expression. Now, as a reminder, we want to completely factor each expression. Then we want to make a list of all the factors. We're going to cross off any duplicates, and then we're going to multiply the remaining factors when it comes to finding these least common denominators. So looking at this latest example, it says, what is the difference of these two rational expressions in simplest form? Well, let's begin by listing all of our factors. And if you don't recognize it, this is going to be x minus 1, x minus 2 is going to be that denominator factored, and of course we have x minus 2. So coming down here, listing all of our possible factors, we have x minus 2, x minus 1, x minus 2, and of course we're going to go ahead and remove the duplicate. And so my common denominator is going to be x minus 2, x minus 1. Of course, minus x minus 2, x minus 1. Okay, so what did I have to multiply my denominator by here in order to get to my common denominator? Well, I used to have an x minus 2, and now I have x minus 2 times x minus 1. So that means I need to multiply by that x minus 1. Value of x minus 1 divided by x minus 1 is 1, so I haven't changed its value. I'm just creating an equivalent expression, or in this case, yeah, an equivalent expression. And my denominator over here on the second term did not change, so I'm just going to carry over my 6x minus 7. And now what I want to do, that I have a common denominator, I need to do some addition and subtraction. And what I experience here is I need to distribute that, so I have a negative 6x and a positive 7. Now I can rewrite that as a numerator as x minus 1 minus 6x plus 7. Now I can combine like terms, and I have x minus 2 over x minus 1, and then combining like terms, I have negative 5x, right? Negative 6x plus 1, and then I am going to have 7 minus 1 is going to give me a 6. And there is my new equivalent expression in simplest form. All right, simplifying complex fractions. A complex fraction is simply a fraction within a fraction. And what you want to do in order to simplify this is you want to find a common denominator of all the fractions in the problem. And well, it looks like this could be rewritten as x divided by 1. And we can find a common denominator of, looking at my denominators, I have a x and a y, so my common denominator could be xy. And once I have that, what I want to do is I want to multiply this expression by the values of my common denominator over the common denominator. And let's see, what does that look like when we do that. We have, okay, so if this is my common denominator, I want to multiply xy over xy, which is the value of 1. And this will give me, let's see how this goes, x squared y. And then remember, when we multiply, right, we are multiplying by the entire expression. So I have to multiply this times this expression and this expression. So I end up with xy over x plus xy over y. And now when I go to simplify, my x over x is going to cancel out. and my y over y is going to cancel out. So I'm going to have x squared y divided by y plus x. And it looks that this is going to be the simplest form that we can't do anything more with. We do not need to do this next example here. So for class, you can go ahead and stop now. If you're looking for a little bit of enrichment, well, we can go ahead and do it. And if I look at remember the first step that I want to do is find a common denominator of all my fractions. And if I list that, I have x plus 1, and x minus 1. And again, x plus 1. Turns out that this x plus 1 could be a duplicate. So then I have a common denominator, and what I want to do is I want to multiply that problem by the x times x plus 1 times x minus 1 over the same. So let's just go ahead and say multiply, and that's going to be x and the same in the numerator. And therefore now we're going to, we have to distribute. So doing this the very long way, I would have x minus 2 as I distribute here times x plus 1 times x minus 1. And again, distributing here, I would have 2 times x plus 1, x minus 1. Now, there are faster ways to do this. I'm just being thorough and trying to show you each one of the steps. And then, of course, doing the same thing with my numerator. I'm going to have 3 times x plus 1, x minus 1 over x minus 1 plus, minus 1 times x Okay, now that we've done the distributive portion of this, what we want to do is we're going to simplify each one of these fractions. And I know that x divided by x is going to be 0. I know that x plus 1 divided by x plus 1, x divided by x is 1. X plus 1 divided by x plus 1 is 1. My x minus 1s cancel out to 1, and then my x plus 1s cancel out over here. So if I rewrite this expression, I'm looking at x minus 2 plus all of that over now. We could possibly be done here, but let's just see what happens in this new denominator. I would have 3x squared plus 3x minus x squared plus x. That would be my new denominator. And when I have that, there's some combining I can do. And I'm not messing with the numerator yet. I'm just looking at this. So as I combine like terms, I'm going to end up with 2x squared plus 4. Gosh, keeps going and going and going, doesn't it? Okay, so I've gone and I've combined like terms up in the numerator, and I've simplified my expression. So I did all my multiplication here plus all my multiplication here gives me this. And this is what it comes to in combined terms. And now I can still factor. turn it into a monster, and I know my numerator, it can factor into 2x times x plus 2, all of that over okay, and then we know that those two are going to cancel out to be 1, and then I'm going to end up with x minus 1 squared over 2x. There you go, in case you wanted to know. That's a very long process, but not necessary at this point in time in our class.